Hi, this is Mrs. Villette, and these notes are for section 5.2 in Sullivan & Sullivan Unit Circle Approach to Precalculus. And in this section, we will look at finding the exact values of points that are on the unit circle, the definitions of the 6 trigonometric functions on a circle, and evaluating those trig functions at unit circle angles. Let's start with the definition of the unit circle. So the unit circle is just a circle of radius 1 centered at the origin in the rectangular coordinate system. So here we have a circle and we center it at the origin, and in order to be the unit circle, then the radius of the circle needs to be 1. Now if you look at the unit circle, you can always create a right triangle for any point on the unit circle. And let's say that point is called xy, then the base of the triangle will be x, and the height will be y, and the hypotenuse will be 1 because it's a unit circle. So just applying the Pythagorean theorem, we see that x squared plus y squared equals 1 is the relationship between all the x and y coordinates on the unit circle. Now we're going to move to a more general circle. So we're going to consider a circle of radius r that's centered at the origin, and we'll let the point P, which has coordinates x, y, be a point that corresponds to a standard position angle theta. And then we're going to define the 6 trigonometric ratios as a function of that angle theta. So you can see over here we have the point P, x, y. And again, we can create that embedded right triangle just by dropping what's called an altitude from the point down to the x-axis in such a manner that it's perpendicular with the x-axis. So this triangle would have a base of x and a height of y. Now we're on a circle of radius r, so the hypotenuse is now the length of the radius, or r. The interesting thing about these trigonometric functions is that they are functions of theta, and we're going to call theta this angle that is formed by taking the positive x-axis as the initial ray, and then wherever the point is that's on the circle, we connect that with the origin to create our terminal ray. So we've got our initial ray here, we've got our terminal ray here, and then theta is the angle that's formed between those two rays. So unlike other functions, trigonometric functions, when you have an angle theta, there is no formula to which you plug in theta. They are ratios of sides on the triangle that corresponds with the angle theta. So we have this angle theta here, but we're going to define our trigonometric ratios in terms of the x, y, and r values from this triangle that we've formed in this manner. You may know from geometry or some other course, SOHCAHTOA, and that's just a memory device so you can remember what the ratios are. So it stands for that the sine is the opposite over the hypotenuse. If I'm looking at this angle theta, the opposite would be the y coordinate of the point, and the hypotenuse would be the radius of the circle. So the sine is the y value divided by r. The ka in SOHCAHTOA means cosine is adjacent over hypotenuse, so x over r. TOA, tangent, is opposite over adjacent, so opposite is y and adjacent is x. Now these other 3 functions are called the reciprocal functions, and I've lined them up so that you can see that the cosecant is the reciprocal of sine. So cosecant would be r over y, secant would be r over x, and cotangent would be x over y. Now I'll always remember for sine and cosine that the cos don't go. So the sine goes with the cosecant, but the cosine does not go with the cosecant. So the cos don't go together. Sine with cosecant, cosine with sine, or you can remember the s goes with the c in terms of the reciprocal, and then the c with the s in terms of the reciprocal. Now tangent and cotangent, those do go together. So let's look at an example. We have an angle theta that's pictured in figure 1, and I haven't actually drawn the angle on there. That's up to us to sort of figure out. We can figure out that the angle is actually right here, And we have a point P that has an x-coordinate of 1/3 and it's on the unit circle. So that means that the radius and the hypotenuse are 1. We need to find the values of the 6 trigonometric functions as a function of theta. So if we started writing these out, sine of theta is y over r, we would realize that we need to know what the y value is, and we don't have the y value. So let's go ahead and take a little detour and find the y value first. We know that the Pythagorean theorem is the underlying relationship on these circles, and since this is a circle of radius 1, x squared plus y squared equals 1 squared. I know that x is 1/3, but I don't know what y is. So I have 1/3 squared plus y squared equals 1, or 1/9 plus y squared equals 1. That means y squared is 8/9, and y is the plus or minus square root of 8/9. I can simplify the square root of 9 to 3, and I can simplify the square root of 8 to 2 square root of 2, and we will choose the positive square root. Because the point P was in the first quadrant, I can see that the y value should be positive. Now this is very important that on all of these problems, when you go from y squared to y, you write that plus or minus and you choose the sign appropriately. So had my theta been over here instead, actually let's not do that. Let's say my theta was in quadrant 4 directly below. So that also has an x-coordinate of 1/3, but it would have the opposite y-coordinate that I just came up with. So I would have chosen the negative square root in that case. Okay, so now we go through. Sine of theta is the y value divided by the r value, and in this case that's 2 root 2 over 3 all over 1, but since the radius is 1, dividing by 1 doesn't really do anything, so we'll say 2 root 2 over 3. Now the cosine of theta is the x-coordinate over the r, and we already know the x-coordinate is 1/3, the radius is 1, so I don't need to write that. The tangent of theta, it's the opposite, or the y, over the x. So I have the y over the x, and you can see that both denominators are 3, and I can just cancel, and I get 2 square root of 2. Now I'll go to my cofunctions. The cosecant of theta is the reciprocal of the sine, so 3 over 2 square root of 2. And we do like to rationalize these answers, so we will multiply the top and the bottom by root 2 over root 2, and we get 3 root 2 over that root 2 times root 2 is 2, 2 times 2 is 4. The secant of theta is the reciprocal of cosine, so that would just be 3. And the cotangent of theta would be 1 over 2 root 2. So again, we rationalize. And we end up with root 2 over 4. So after this, we're going to talk about points that correspond to some important angles on the unit circle. So namely our angles that are 1/12 of the way around, 1/6 of the way around, 1/8, 1/4, 1/2, etc. And after that, we will start evaluating sine, cosine, tangent, etc. for those particular unit circle angles.